Welcome to section 1.7, an introduction to functions. The goal that we have for today is we want to identify a function, make an input-output table for a function, and write an equation for a real-life function. So first thing we want to do is your exploration. Work with a partner. Use the number line below. Draw a stick figure showing the height of a person that they go from 1st to 12th grade. So we want to see how they differ going from 1st grade to 12th grade. We're going to let you do that. We're going to talk about that one in class. On to the notes. A function is a rule that establishes a relationship between two quantities called the input and the output. For each input, there is exactly one output. Making an input dash output table is one way to describe a function. The collection of all input values is the domain of the function. The collection of all output values is the range of the function. So, does each of the following tables represent a function? We want to explain. So in this one, is this a function? For every input, is there exactly one output? Well, 5 has the output of 1. But then 5 also has the input of 2. So every input should only have one output, but 5 has 2 outputs. It has the outputs of 1 and 2. So this right here is not a function. Now, the quick and easy way to determine whether it is a function or not is just by looking at the inputs. Are there any duplicate values? So since there are 2 duplicate values, we know that this is not a function. On the second one, I have 1, 2, 3, and 4. There's only one output for 1, only one output for 2, only one output for 3, and only one output for 4. Notice that there's no repeatings. So since there's no repeating numbers, we know that this is a function. So this is a function. On the third one, notice we have 2 numbers that are the same, 1 and 1. So this tells us that 1 has 2 outputs, but we remember a function only has 1 output for every input. So in this case, because we have those repeating ones right here, this is not a function. Go ahead and try the U-practice. And we're going to look at example number 2. We want to make an input-output table for each of the functions. Use 0, 1, 2, and 3 as to the domain. As the domain. So our input for each of these values is going to be 0, 1, 2, and 3. So I can plug in my input 0, 1, 2, and 3. This will be true for all these cases. So if I do this, I'm going to do my output. So I know 0, 3 times 0 is 0. 0 plus 1 is 1. 3 times 1 is 3. 3 plus 1 is 4. 2. 3 times 2 is 6. 6 plus 1 is 7. 3 times 3 is 9. 9 plus 1 is 10. You'll also notice a pattern. These are all going up by 1s. These are all going up by 3s. So there's often a pattern that you can see when you're doing these types of problems. Notice these are all going by 1s, these are all going by 1s. So probably there's going to be a pattern for the output. So if I do 0, 0 plus 5 is 5. 1. 1 plus 5 is 6. It has a difference of 1, so I'm guessing this is going to be a 7, but let's double check. 2 plus 5 is 7. I'm guessing this is an 8, but let's just make sure. 3 plus 5 is in fact an 8. So again, you see the pattern. On this case, my input, I'm going to plug in 0. 5 minus 0 is 5. 5 minus 1 is 4. Looks like it's decreasing by 1, so this is probably going to be a 3, but let's just check. 5 minus 2 is in fact 3, and this will be a 2 because 5 minus 3 is 2. Go ahead and try the U practice. And example number 3, a word problem. The county fair charges $4 per vehicle and $1.50 for each person in the vehicle. Represent the total charge as C as a function of the number of persons P. Write an equation for the function. So we know that we're looking for the total charge. So we're going to have C is equal to some value. Now we know that when a person comes in to the county fair, they're automatically going to be charged $4 per vehicle. So we know $4 is how much they're going to be charged. So we're going to add 4 to this. It's not going to change. It's always going to be plus 4. You're always going to have $4. If one person comes by themselves, they're only going to be charged for themselves. So it's going to be $1.50. If 2 people come, then they're going to be added another 3. They're going to be charged $3. If 3 people come, that's going to be $4.50. If 4 people come, that's going to be $6. So all you're doing is taking the number of people and multiplying by $1.50. So this would be 1.5 times the number of people. And that is my equation that I'm looking for.